Hi, the section 6.2, the residuals and fitted values. The fitted value, the fitted function or fitted dot values, the function or just the fifth object of the LM object, the LM15, for example, the return the fitted values, the y hat. So y hat is the expected value of y when only x is given. So here we have a graph. So we are given the several data points. Then we fit the regression line. Then given just the value of x, the best estimate for y is this point. So this is called the y hat. So in matrix form, the y hat is equal to x times the beta hat. So y hat is just the all predicted value. If we use the all existing observations, basically for each observation that we calculate the y hat. For this observation here, this observation here, this observation here, this observation here, for this observation here. So if the x is the design matrix or model matrix, then this is n by 2, beta hat is 2 by 1. So we get all the predicted value for y. So the y1 maybe 360 or 400, but actually they're given only the x value. The best estimate for y is 384. And LM of 1 or fitted value of LM1. So these commands that return the same result. Okay, so the fitted values are just the best estimate given x. And next to the residuals. The residuals is the y minus x beta hat. So remember that originally the linear model is y is equal to x beta plus epsilon, but the beta is not observed. So we estimate beta. So we make it as the beta hat. Then epsilon is also approximate. So we say that as epsilon hat. And epsilon hat is often used to check the assumption of epsilon. Often the biggest assumption in a linear model is epsilon follows IID and also sometimes normal, we assume, if we would like to do tests for coefficients. Yeah, so if we check the residuals and it has some distinctive pattern and it's not really IID normal, then we have to develop another model or we have to the modified model. So this is the residual. So the first observation, the residual is 405.9. So that means if we have data set, we have x and y, and we have the data points 1, 2, 3, 4, 5, and we have straight line, then this size. This is residual. In this case, the residual is negative because the point is below this regression line. If above, residual is positive. So this is basically the deviation from the theory. So the best estimate given x value, for example, x value is here, but actual value is below. So something below this expected value. So the discrepancy is called residual. And the residual can be obtained by $ residual or resid of LM object or LM1 of 2. So this is the residual plot. Maybe it's easier to see when we have baseline y is equal to 0. You can put this by the command, the AB line, slope, the intercept of 0 and the slope of 0. Yeah, then is there any pattern in this residual? At first, this x-axis is the square footage, so this is x. and this is residual, so epsilon hat. And you can see that we have this distinctive pattern in the variability of these errors. That means if x is smaller, then error size in absolute value is smaller, but x gets larger, the error gets larger. So we only have 2 observations, so we are not sure around here, but at least until the 3000 or 3500, we have increasing the variance here. And possibly another problem is we have the several observations, the cluster here. So all observations around 3000 have negative residuals. So that means the condominium has 3000 square footage in Detroit. The price is lower than the trend line. So maybe because there is just the condominium building in Detroit which has mostly 3000 square feet the units. So if like this, it violates the assumption, the IID assumption, normal IID assumption of epsilon, we have to do some improvement. We have to adjust it. And the one possible remedy for this specific case is to transform the both variables. Because x is larger, then error is also larger. So error size is also larger. So that is somewhat natural in some cases. For example, we fit the for example, the measured weight on y and maybe measured weight in y and the actual weight is on x. Then if actual weight is larger, then the measurement error also gets larger. So it's pretty natural. So usually the measurement error is more consistent in percentage something. So in such a case, we have to transform variables x and y. So in this specific case, probably we transform the y at least because the error size, that is the vertical distance, is larger for larger x. So one possibility is maybe log of y on x, or also the relationship is also almost linear originally. So maybe we take the logarithm for both x and y. And another remedy is just look into the observations with around 3000 square feet. So something may have happened. So realistically, we have to separate the case. So the point is that the residuals are important to see if the assumptions of the linear model is correct. And another assumption often that we assume is the normality. And the QQ plot diagnose whether or not residuals are IID, normal, sorry, normal. So normal QQ plot, basically the x-axis, the theoretical quantiles, and y-axis, the sample quantiles. So if all observations are almost on the same straight line, then we can say it's almost normal. And in this case, it's pretty good that we have some curvature in moderate range, but it's pretty good that all very large observations and small observations are almost in line with the theoretical quantile. This is actually pretty beautiful QQ plot. Often we have some curvature such as this or this or this or maybe this. So we have this kind of shape, but in this case, it's almost straight line. Yeah, so to be exact, we need some standardization and the residuals, to be exact residual epsilon hat that does not follow the normal distribution because this is epsilon hat. So epsilon is normal, but the epsilon hat is not normal. So the analysis is not 100% valid, but approximately normal, I would say, epsilon hat. Anyway, this is estimated epsilon. So because of the difference between epsilon and epsilon hat, actually, it's not exactly normal. So epsilon hat is not normal, even if epsilon is normal. Yeah, so exercise that we have the several points, 1, 2, 3, 4, 5, 6, 7 points. So this is for the quiz. So you can plot the residual over, okay, so you can plot X here and the residual here, and you can see there what's happening